let us talk about digital logic. So here two words are there, one is digital and other is logic. So let's try to understand that what this course is about. So this course covers the basics of switching theory and logic design that is necessary to analyze and design combinational circuits and sequential circuits. Now these combinational and sequential circuits are the building blocks for modern processor design, right, at switch, gate and resistor levels. Right. So if you talk about a digital system, so one of the best known example of digital systems around us that we are using in our daily life, that is our this digital computing systems. So these digital computing systems are built on top of this particular course or whatever elements we study in this particular course. Now this course hides the pitfalls of analog world because the analog world contains errors, right? Now those errors are approximated, or I can say the analog electronics world, by mapping all physical values as sequence of zeros and ones. So these zeros are the abstractions of low voltages and these ones are the abstractions of high voltages, or it can be vice versa as well, that is according to positive logic system or negative logic system, right? So the electrical voltage levels are abstracted as zeros and ones. So that's the idea of, that is the primary idea of digital logic. Now what does this word digital mean? The word digital implies that the information or the data that we are storing in a digital computer, that is information in the computer, is represented by variables that can take limited number of discrete values. So one of the best example of discrete object in mathematics is the set of natural numbers, or I can say the set of natural numbers less than 7. So the set will contain 1, 2, 3, 4, 5, 6 all the way up to 7. So 7 distinct elements, right? Now if I am talking about the digital computing systems, these systems are aware of only zeros and ones. So hence we follow the binary number system here, or the binary system over here, right? Now these values are processed internally by these components which we study under the course of digital logic, so that can maintain a limited number of discrete states, and that leads to that takes us towards minimization of errors. So because of this, the errors that can occur in a system gets minimized because we limit the number of discrete states over here, right? Now why one should be even bothered about studying about this course? So we are aware of the fact that the general purpose digital computer is one of the best known example of digital system that exist today out of multiple, right? Now the major part of this digital computing system are the memory unit, the central processing unit for processing data, and then IO units, that is input output units. Now the purpose of memory unit is to store programs and data. So programs along with the input, output and the intermediate data when the programs are performing some operations, the program instructions, right? So that is the purpose of memory. And again, this memory is built on top of various combinational and sequential circuits, right? Now if you consider about, if you consider this central processing unit, so this performs the arithmetic and data processing operations, such as the arithmetic operations can be addition, subtraction, multiplication, division, right? So for adding we need half adder circuit, then full adders, carry look ahead adders, subtractor circuits, multiplier circuits and so on. And for performing floating point operations we need floating point units as well, right? And for data processing, for example data transfer, transferring the data from register to memory, memory to register, right? So these operations are performed by the CPU, and CPU in turn consists of arithmetic logic unit, control unit and registers, and again these components are built on top of this particular course, right? So that is where this becomes very important that one should study about this course in detail. Next, to write better software application. So when you study about this course, you get to study about tools and techniques using Boolean algebra, so that your bit manipulation techniques becomes better, and using this better bit manipulation techniques you will be able to write better software. Then the next most important point, we get a better understanding of hardware, right? And from this point this follows here that this course serves as the foundation for many other courses in computer science, right, and engineering. So one of the courses computer architecture. So this is the umbrella term for microarchitecture, computer design, system design and so on, right? Again computer networks. So this course is dependency on many other advanced courses. So if you are having a better grip on this course, then with the help of the topics that you study in this course, it will help you in other upcoming courses as well, right? Then the topics that we cover under this course are majorly, we have data and we want to represent data in computer systems. So for that, we should have a proper clarity on this number representations. Then once we have represented the data, we want to perform manipulations. So for that, computer arithmetic. Then next is Boolean algebra. So this serves as the tool for developing combinational and sequential circuits. So these are the major topics which we study. Under combinational circuits, we study about half adder, full adder, carry look ahead adder, encoders, decoders, multiplexer, demultiplexer, right, BCD converters, and so on. Then wherever memory elements are required, then we go for the sequential circuits. So here we study about various flip-flops, right? Then we study about the memory elements like finite state machines, etc., right? Now apart from all of this, you might ask that in industry, which which are the set of companies, or what are the set of companies who are asking this? So what I personally feel is that Google as a company is the one which sets the benchmark for most of the software engineering interviews, right? So this is the official page of software engineering interview prep guide from Google. So if you observe here, they mention this term, something called as low level hardware. So during the interviews, if they're asking about, if they're mentioning this term, that is low level hardware, then definitely this course has a relevance in interviews as well. Then networking courses, right? Storage, computations, distributed systems. So these are some of the advanced courses which are built on top of this course of digital logic, and hence this course becomes one of the most important course for any computer engineer on earth.